Actually, I don't know if we're going through the Wi-Fi or if we're going through the other thing. That's pretty sick. See, look, we're back with the fast internet. Doesn't get much faster than that now, does it? All right, we got a monitor over here to put chat up on. Hopefully you guys can hear me. I'm not like muted. We got a Starbucks. And we got seaweed for eating. So seaweed. You want a seaweed? Seaweed. You know, I'm back in San Diego. It's by the sea. A lot of good seaweed here. You got 35 megabits. Well, that's slow. We got 1.2 gigabits back somewhere where the internet is fast. Yes, back in San Diego, yes. Hello, hello, hello. That can go over here. Got ChatGPT up over here. Yeah. How not to be a noob. Okay, so let's start with showing you guys Viz if you haven't seen Viz, and it's a good place to start and a good place to think about stuff, okay? So Viz is built into tinygrad, and it loads up a web browser. So you can see these are all the kernels. Maybe we'll just limit it to one. We'll just do one test. We'll do test tiny.testgem. Okay. So these are just setup kernels. I don't even know what that's doing. Oh, maybe that's an A range or something. I don't even know what that is. But regardless, this is the gem kernel. You can see pretty clearly that it's a gem. Oh, that font looks extra crispy and brave. What's happened with tinygrad since last stream? A lot of stuff. So one of the biggest changes is the scheduler. So you can see, like, this is the tensor graph. This is the graph from the tensors. And then what we actually return is, to be honest, I'm not sure what that does. But yeah, if you apply the kernelize map, why is that still there? Well, this isn't the part I worked on, so we're all learning together. I don't understand why there's still a reduce there and why that's not in a kernel. It should be in a kernel. Maybe the last one doesn't. Okay, that's fine. Either way, we can see it here in create AST that there's 4 kernels and one of them is a copy. So we can go here and run with debug equals 2. You can see there's 4 kernels and one of them is a copy. There's these 2 kernels here, which set up. We can read the test that it's running over here. Yeah, so, oh, that's an I. So tensor 1, tensor I, then it's multiplying those together. And it's making sure that, so an I should just be the identity matrix, and it's making sure that they're all equal 1. So that's pretty nice. Yeah, you can see this is just ones. So for every single one, we just store ones. We can look at the final code that actually does that. Yeah, it's nothing. That's the code here. You can see that it's just storing ones. Store lots of ones. All right, so this is the final code for I. Everything's a bit easier to see if we run it with no opt, so we can try that for now. And yeah, so this is the ones kernel. You can see that it's literally just for every GIDX, just storing 1. There's 496 of them. This is the I kernel. So yeah, that computes whether it's the I mean, that makes sense, right? If it's mod 65, right? So this is making the identity matrix, right? You're just putting the ones down the line. So if it's mod 65, because it's 64 by 64 matrix, you set that one to 1. Otherwise, you set it to 0. And then we just store that in the output there. Then this is the matmul. So you can see that it's got 64 by 64 global IDXs. And then we have a loop here, which adds up the 64 and does the dot product and then stores it. Ooh, all the compiled UPATs really show up there. So, oh yeah, that's something else that changed. Wait, what? Why did those happen after? Oh, interesting. So now the pattern matcher itself is a pattern matcher, and it's a lot faster. So we actually use the pattern matcher to compile pattern matchers. Everything got a little meta. But the output code is still very simple, and you can see all the steps that it basically goes through for a kernel here. Okay, so this is the scheduler. The scheduler is deciding, given the tensor graph, how to group things into kernels. So because we have contiguouses here, a contiguous has to be the end of a kernel. So this is the contiguous that's setting them all to 1. This is the tensor I. You can see that it's actually just a trick, like a view. Right, because you can just view and then slice. See how you can make an I matrix out of that? And then, yeah, this is the matmul. So you can see that it has 0 on those axes. It's multiplied. It's reduced. We view it as a 1D tensor in order to do the copy back to the CPU. And then there's a sync, and that's just the end of the graph. So over here, you can see that those are grouped into ASTs. Ideally, there should be a way to click on these kernels and get to the actual kernels. Those are the kernels, but that's all stuff to be worked on later. We unbind any variables. If it was using that. Oh, here, view kernel graph is the one I'm thinking of. So view kernel graph here. The good ones are the views. So if you view kernel graph, view tensor graph shows you like what you put in the tensors. View kernel graph shows you how it's kernelized, and then view memory graph shows you the memory utilization. And if I click profiler, is it still? Nope, doesn't work yet. Okay, great. Where's the Python code box above the kernel code? The code is here. Why do you think there's Python code? All right, so then these are all the steps. These compile and process UPATs, you know what? I'm just going to not log them. So we're not going to see those because those are really unrelated to the actual kernel. So let's take a look now and say, okay, good, they're gone. Okay. So this is the full compilation flow. There's something here that's kind of in the compilation flow. So if we go to this one, you'll see that there's a step which replaces the buffers with like kind of like placeholders. And this is a common operation. We probably just want to think about how to do that more generically. So you see, like, that's called like define global 0, that's define global 1, and define global 2. But yeah, like what that really is doing is like kind of blocking. It's creating a block, and we can do the same thing with reduces. So that's like the long-term dream is some way to like, it's a long story. To deal with like, you have like recursive structure, and it's so many problems in neural network compilation. look like keyboard shortcut? Oh, well, keyboard got banned. Okay, we're putting on subscribers only. Please keep chat on topic. If you're going to say off-topic stuff, you can get banned from my stream. So please try to pay attention. This isn't that hard. If you're not here to pay attention, why are you here? My quote, my high school yearbook, if something is worth doing, it's worth doing well. There's just a lot of things not worth doing. And this is dirty. No one's cleaned this desk in a long time. I can tell. So, yeah. So you see that we replaced the buffer with these placeholders, these defined global placeholders. But really, that's like a super generic operation that we also want to use in other places to deal with the recursive structure of graphs. So that's kind of where I see tinygrad going, to the point that it can like just recursively deal with each section. Oh, that's so beautiful. Oh, that's so beautiful. Like things just have like scope. Oh, yeah. You see what I'm saying? Like you think about what the scope is of a kernel. There shouldn't be a thing called a kernel anymore. Oh, the diff is just this one rewrite rule. So it looks like this rule applied here replaces that view. So see this diff here is going to replace it with a buffer. So it was a buffer and now it's not a buffer. So this buffer is gone. And then that replaced this view with that view. Like it took this view here and pushed it through. So yeah, and you can use the left and right arrow. Wow, this stuff's really not like exposed anywhere, that you can use the left and right arrow to move. I use Viz all the time now. Yeah, wow. No, we got to just think about, wow, maybe it's time to actually start thinking about that refactor. It's refactors all the way down. Okay, then this is what the compilation flow of a kernel looks like. And it's all using uops, and I think eventually... Yeah, I mean, uops can have multiple outputs. The squares are uops, yeah. The squares are uops, and every single one of them has a value. So you can really like see it here in the tensor graph, like because this one's convenient because it like shows you the shape. So you can see that these are, you have two tensors that are 64 by 64. We do some view uops on them, which these are the strides. So you can see that this is stride 0, this is stride 0. Then we do a mul, that's dense. Then we do a reduce on axis 2. So it's keep dims, right? So we keep all the dimensions, but it's now 64, 64, 1 because we did a reduce ops add on that. And then here we do a view to flatten it, a contiguous to put it in a kernel, and a copy back to the CPU. Okay, so that's like the overworld, the scheduler overworld. Yeah, I know it should be the default in every neural network library. Yeah. Guys, like tinygrad's really good. It's just, oh, we just keep refactoring, and there's still so much more refactors to do. Yeah, so then these are the kernels that are actually run, and you can see the compilation flow of the kernel here. So I should label this one. What is kernel 531? I don't know, we had this like for some reason they weren't labeled. Kernel 531, what does this do? Fix up optimized AST. So nothing actually happens there because we've disabled optimizations. Let's get the lower 239. It's actually a fine name for it because it's just a lower. That's the expander. I should probably just move all these to somewhere else. The ignore stuff's kind of annoying. I'm not even sure how well tested that is. Devectorizer, then the linearizer, create blocks, which like puts things into blocks, and then we merge the blocks together. Place that with that. End of the year, yeah, I think still the end of the year we should be competitive with Torch for speed. So we can get to some of the stuff where we're not competitive with Torch for speed. So here, I can show you something. So this here is a, I disabled the, I put the optimizer back on. So you can see that now the map mul is a lot more complicated. And it's really complicated because it's using tensor cores. So we have this wham a 88 float float helper thread elements. That's cool. Okay, so this gets into some. I never explain anything well, do I? It's hard to like explain. I'm so much better at explaining stuff when I have another person who I'm explaining stuff to, and not some hypothetical person. How the vectorizer works? Well, we don't have a vectorizer, we have a devectorizer. So you can see like this here is something that this like vectorize int 32 is just like a broadcast. And then we're adding this as a vconst where each one of these is this value. And then this is like a vec32d type, right? So, but yeah, this brings up an issue, which is, you see the local IDX? The local IDX has d types int, but it kind of doesn't. So these light blue dimensions here are the warp, and the warp really needs to be upcasted. None of these words make any sense. Like, none of this shit makes any sense to anybody. It's D3 to draw the graphs, but it's in a web browser. Everybody go right now, pip install tinygrad, or install it from master. Really, you should install it from master, and then run with viz equals 1. Here, take this command, take that command, and go run it. Go run it on your home computer. Tinygrad's super easy to install. Let me know if you have any problems. This is the technical support session for tinygrad. So then you can get this right on your computer. It doesn't even require an internet connection. All this stuff's local. Yeah, again, there's like, no one paid attention to my last video. So when I ask you what a warp is, do you know what a warp is? Remember on these streams when we used to do projects that were accessible to everybody? That shit was stupid. Yeah, so everybody go try tinygrad right now on their home computer, and I'll help debug issues with you. It didn't account for NVIDIA being smart and the register dependencies. I don't know about that. What's the Quentin days? I don't even remember what used to happen on this stream. It's been so long. So much has changed. All right, so who's excited for the economy to plummet? I take back every good thing I said about the current regime. Who's excited for the economy to plummet? You know, it's going down, down and early around. And sugar, we're going down swinging. We can turn off subscriber only chat just so everybody's excited for the economy. This is like, it's fucking bullshit. Like, yeah. Yep. So, you know, I take it back. I didn't actually vote in 2024. I'm glad I didn't vote. Even la would be better if we didn't have to have tariffs. We can bring DEI back in exchange for no tariffs. What do you guys think? DEI, no tariffs? Is that a worthwhile trade? Yeah, no. This was great until we had fucking economic suicide. It's and like, you guys don't even realize, I think it's going to be so much worse than a lot of people are expecting. I also can't believe these people know nothing about China. Like, you don't work with China because they're cheap. You work with China because they're the best. Yeah, so. All right. I didn't want to go too long into that tangent, but just so you know, no one thinks, oh, I'm a shill for this. I'm not a shill for this. I'm distancing myself from it. But you know what? It doesn't even fucking matter. You just got to realize that your life is out of your hands, and you know let's all go through the Serenity Prayer, okay? All right, you guys know the Serenity Prayer? All right. God, grant me the serenity to accept the things I cannot change, the courage to change the things I can, and the wisdom to know the difference. I'll also offer up another quote, and then that could be the end of this topic. Once upon a time, Bart Simpson said, "This is the worst day of my life." And Homer corrected him, "No, this is the worst day of your life so far." Yeah, I'm all for bringing manufacturing back to America, but I'll tell you exactly what I'm going to do as a result of this shit. I can't manufacture in America if I have to pay huge tariffs on all my imports. 30-40% of what I sell is overseas. I can't make that in an American factory. I'm going to go make it in a foreign factory now. I actually was doing manufacturing in America, and now it's going to be less due to the tariffs. And for someone who's like, but George, you can do clawbacks, and there's this regulation to help you. Fuck regulations. The tariffs are just regulations and taxes. That's all they are. There's no other way to put it, right? Like I wanted someone who was going to deregulate shit, not pass a whole new set of regulations. I'm getting emails from fucking people saying, "Hi, I want to be a tariff consultant for your business. I can help you navigate these rocky water." Fuck you. Like, that's more PMC shit. Yeah, China pays the tariffs, my ass. And Mexico pay for the wall too. No, I liked what the Canadian guy did. The new Canadian guy. You know, Trump was talking. He's talking shit. Like, you gotta stop doing that. I'm all for it. I love America first. You know, the comma DEI shit needed to go, but you can't threaten like to like annex Canada. What are you, Putin? Oh yeah, we're annexing Canada. So the Canadian Prime Minister's like, dude, like, stop saying that shit, or we're gonna dump all our American debt. So yeah, no, it's too much. It's really too much. But again, I'm not big on listening to talk. You know, everyone's like, oh, mean tweets. I don't give a shit about mean tweets. You know what I care about? Regulations, taxes, and bad economy. You make number go up. I'm a number go up, bro. Okay, I vote for number go up. I want all numbers to go up, all good numbers. Okay, like electricity production. Shit needs to go up. That's what I can't stand about Democrats. These people believe in deceleration. These people believe in less electricities. We need more electricities. Number needs to go up. All right, you've seen this? You've seen this? You know, we're going to look at this graph every stream until something changes. Okay, look at China's number. It's going up. You're not going to beat China by putting a tariff on China. You're going to beat China by making your number go up faster. I thought we were on the number go up team. Nope. Turns out we get fucking tariffs. And that's why, you know, you never know how bad it's going to get. You know, if you're ever thinking of killing yourself, just remember that something even dumber can happen tomorrow. Yeah, you're not going to fuck China over. You're going to fuck yourself over. Right? Oh, no, here, I heard a good one. Okay, so a man walks into a coffee shop and buys a $5 coffee. But when he leaves the coffee shop, he realizes that he now has a trade deficit with that coffee shop. So he's going to impose a 50% tariff on that coffee shop. And then he goes in there the next day and the coffee costs $7.50. Okay? So you know that's what just happened. No, look, I'm all for. I'm supportive of deportation of everyone who came here illegally. You can't cross the border illegally. You get deported if you do that. I'm supportive of that. You know, again, start with criminals, but that doesn't have anything to do with legal immigration. I also support legal immigration, right? It's the same thing. Like, I also support voter ID. Like, I want to have fair elections, but I don't support, you know, making the polling place on the top of a mountain, right? I don't support restrictions. See, it's like you can't have this anymore. You can't have any common sense. You can't. You just like it's like everyone's racing to be the stupidest guy in the room, right? Like, we have to be, because you got to do something, right? I don't know. This gets me going now. But you know what? Like, I'm so disappointed. I am so disappointed. All I wanted was, like, bros who were going to make the number go up, right? The Democrats think the number going up is bad, and the Republicans want to screw over China more than they want the number to go up or something, or screw over illegals or whatever. I don't really care about China, illegals, tariffs, DEI, all of this shit. I don't care. I just want the number to fucking go up, right? Can we make the number go up? I don't even know. Like, you can't even follow the news. Like, you guys know my blog. I wrote some blog posts about this. But yeah, like, it's the economy, stupid. Down. Yeah, no. And then, like, Elon, I don't know. I think, from what I heard, he tried to stop the tariffs. He obviously knows better. I don't know. I think no one's more disheartened than him by this. But also, who knows? Maybe the right-wing propaganda is stronger on him than the common sense. But I don't know. Yep. No, I know. And everybody. It's crazy how the U.S. spent 50 years creating the rules of international trade. Then China played by the rules. That's the other. Like, the idea that China is somehow like that we're buying all the Chinese goods and China's buying nothing from us clearly shows no one's been to China. Go to China. They have Starbucks, they have KFC, they have McDonald's, they have iPhones, and it competes on a level playing field. There's so many American brands in China. It's just crazy to me. Tesla's big in China. Yeah. So this is just literally being a sore loser. Can we just try to beat them on their terms? We can beat them, but, like, let's not be stupid, right? Also, like, oh my God, the AI Diffusion Act. If I'm Jensen, I'm like you just nationalized NVIDIA. I said that on Lex. I said they were going to nationalize NVIDIA. You do understand that the AI Diffusion Act is nationalization with American characteristics, right? Like, that's all it is. Saying that NVIDIA is only allowed to sell GPUs to 18 countries. I have to pay attention to which country I'm exporting tinybox V2s to. For sale, by the way. We are going to make them. I got some 5090s, boys. So if you're interested, if you buy this, I should be able to ship it to you by the end of May. And for the 3 people who already gave me money, you should get yours maybe even this week or the week after, depending on how the software goes. Why would China import from the U.S.? Well, but the U.S. has a lot of strengths. The U.S. has, like, have you tried a Chinese GPU? It's awful. The U.S. is better at that kind of stuff. We're not selling tiny boxes without the cards. You know why we're not? Because then I'm going to get an email. I put this card in and it didn't work. Please help. Nope. No, I don't know about a Redbox V2, but if you want, please buy it. Like we have to sell. I have 4 red boxes ready to ship and like another 4 I can build. So yeah, if anyone's interested, please buy a red box. You can have one just like this one here. This is Tiny 32. It's a red box. Good, no one's doing anything on it. Wow, SSH is so fast now, because that box is like in this office. Only one's been initted. Wow, it's so crazy to have SSH be fast. What? Who broke this shit? How did that break? Did someone like upgrade the Rock M or something? Set option list. Okay, well, that's annoying. This one must have weird, but we can also enable AMD LLVM equals 1, and that will compile all the AMD stuff with LLVM, and we'll see if that works. AMD with LLVM backend requires LLVM 18 plus. Oh, never mind. This shit's unusable. Guys, you don't understand. 80% of people want to bring manufacturing jobs back to America, but only 20% of Americans want to work in a manufacturing job. Interesting. I'll go to my rolling skills. Yes, yes. Democrats have critical race theory and Republicans have critical trade theory, and they're both equally stupid. That's true. Actually, yeah, they're both equally stupid. They both make number go down. And we like when number go up. Okay? Can we just get on board that we want numbers to go up? Can we just make the number go up party? And they just focus on, like, making the number go up, and they just listen to economists, and they're like, sirs, what can we do to make the number go up? And the economists are like, yeah, you can do free trade and merit-based hiring. Wow, brilliant. We're all going to be so rich. But it's really, actually, it's all the same underlying thing. It's just merit. You remove all the artificial barriers to merit. Because the only people who don't want merit are losers. It's that simple. You can't have free trade with China. They're better at making things than us. Oh, no. You can't have fair hiring practices like that. You don't say that one. But yeah, no, it's true, right? It's the same shit. Wait, it's the same. Oh, shit. It's all the same. It's all the same. Oh, my God. It's all the same. It's all fucking DEI shit. Oh, my God. It's just DEI. Oh, we got so scammed. We got so scammed. We got so scammed. It's DEI. They just changed the color of the people. Oh, no. What's wrong with DEI? You see, Americans can't compete against Chinese, so they pass DEI laws to make trade with China expensive. Yeah. It's just DEI. It's all the same shit. They made the number go down. You can't make the number go down. No, but finally we're going to stick it to the billionaires. What are you, some kind of Democrat? I thought you were the number go up people. I'd rather the Democrats. I think they don't even make the number go down. They just give lip service to the number going down. But then don't do retarded shit. You see. You see, if there's difference in earning between the two races, that must be due to racism. And if there's difference in trade between two countries, that must be due to unfair trade practices. Oh, see, I wish I was more competitive. Unemployed 3 years. I wouldn't mind my gov to use BS to advantage me. What you just said is that you're a fucking mooch, dude. Like, I'm a mooch. Oh, he knew about the tariffs. And no one listened. Peter Retardo. Now, if you want to be... How about we deport all the mooches? Oh, that'd be a nice country. If we just deported all the mooches, oh, that'd be great. That'd be great. Let's import some immigrants who want to not be mooches and deport all the mooches. I mean, yeah, I know you hate being a mooch, but like it doesn't make it okay to mooch, right? Like figure out something you can do and figure out how to produce value for other people so we can go back to living in a society. Pooch is right. And don't kill squirrels either. Yeah. What do you mean by disabled? Figure out some way to produce value for other people. right? Look at Stephen Hawking, man. Look at Stephen Hawking. Guy couldn't talk. He was in a wheelchair and still produced tons of value. Look at that. Well, I'm disabled. I can't produce value. No, you're disabled. Get the fuck over it and produce value for other people. Is fear of China justified? What are you afraid they're going to do? They're going to make the world nice? Yeah, look at the third Neuralink patient. There we go. Exactly. Everybody needs to produce value for other people. Okay. Where were we? Let's go back to, is the U.S. afraid of Greenland? I mean, you guys hear about the murder in Greenland, right? There was a town in Greenland that had 3 people, and then there was a murder. And then there were 2 people. And you gotta ask some questions. There's only a few hypotheses about what could have happened here. So the police were sent down to investigate, and they looked into it, and they couldn't find any evidence. And by the time this article was written, both people had moved out of the town. Yeah. Right? Like, we used to troll people like taxes are between you and your government, but now we're going to start doing this to U.S. people. Like, we're just passing the tariffs on to the consumer. Everybody's going to pass the tariffs on to the consumer. Nobody's actually paying this shit. And then consumers are just going to have less purchasing power. All right, you got me started on tariffs. They've been pissing me off. They make my life harder. Things will probably get faster if we switch to non-devectorized. We could probably start doing that a bit. So this morning I removed the... should I be using Clang? You don't have to use Clang. Okay, so you're trying to understand Viz. You want me to explain the steps in the left column. Okay, so these big things are like the contexts. So I'm running a test gem, which is just doing 1 gem. This is the scheduling of that gem, and then this is the 3 kernels. So here, we can try something a little bit more complex. Let's run beautiful MNest. We'll see how all this works. So this is an MNest trainer, and we're going to see if Viz can run on this. Should be able to. Okay, so we see a lot more this time. There's a big schedule up here, a whole lot of kernels, and then we have a whole lot of little schedules here. These are the test kernels. You just kind of have to know this stuff. This is the training step. So we can like view the tensor graph here. It's big. But yeah, so you can basically see this is the forward pass, loss function, backwards pass, and then this is the optimizer all here. You can see signs. Like that's like a step of the optimizer. So you can see the learning rate is something like 0.1 or something. Or I don't know, that's probably updating one of the momentum tensors. It's using Atom. Yeah. Yeah, so then these are all the tensors. This is going to be something like doesn't even look like a convolution. This looks like a straight up matmul. this a convolution? We should really have the metadata here. We can tell you what these things are. So you'll see if I run it with debug equals 2, you can see all the metadata here that tells you like what it's a part of. So this is where we like select the data, max pools and convs. That's just not right. Why is a relu? Oh no, is that a conv? Why does the relu have an R? There's probably some bugs in this stuff too. There's been a lot of refactors going on. Okay, so let's try to work through an entire example. We'll do the no opt gem. You can always say no opt equals 1 if you want to see them without optimizations. And then all you're going to get are dark blue and red, and dark blue are globals and red are reduce. So yeah, so here's the base of the AST of the mapmol. So this lower is going to transform these views into indexing. So you'll see we'll just do one here. So instead of having an arbitrary thing called a view, we actually convert that to an index. It's GIDX1, range 2 on define global 1. This is a buffer. And we do an index, and then we do a load. So you see it replaces this view with that actual indexing. We'll replace the other ones too. That constitute true goes away because we don't have a, that true just means it doesn't have a mask. Not exactly sure why that's getting made at all, but whatever. That there, that goes away. What's that doing? Oh yeah, so this is a reduce axis, but we rewrite the reduce axis to just be a reduce that points to the range. So you can see now that this has kind of formed the loop here. You can kind of see the structure of the loop, like the range, and then it's closed by this reduce. And everything that's in the set of nodes between the two is a reduce. You'll see we can zoom in more on that later. We'll do the same thing for the store. Notice how all UOPs are perfectly deduped. So like we don't actually create copies of any UOPs. It'll just point to the UOP if it's already in the graph. Yeah, so that's the store. And then what does this last one do here? Oh, it just gets rid of that true. Wow, there's lots of trues there. Let me see if we can just fix that to not do that. So this is the lower that's actually doing that. Shouldn't really put resolve there. It's fine. It's fine that it just removes it. You really want like code simplicity. Like we can check if valid. Well, I guess I could just do that. Nah, we're just gonna leave that. All right, so where were we? Yeah, so that's good. That gets rid of those trues. You could imagine a world in which it never even like creates the UOP and just knows that it has to apply that one to it next. Like you can imagine these rules, like working out the rules symbolically. That's kind of where the compiler goes. But okay, so that's the lower. You can see before and after the lower. Before we have the views. After the lower, we have lowered. There's no expanding because this is a non-optimized kernel. These ignores are used for masking. If the store is masked, you can ignore a lot of stuff. This stuff's mostly used for the DSP. Again, we have no expanding. What is this migrate indexing? Do we still need that? Create gate must be before expander. Oh, this stuff's so annoying. It's really just got to go through and refactor all of this and see like what we just don't need anymore. Now that things are a lot simpler. Okay. Then we see if we can collapse the reduce. We can't collapse this reduce, but I can show you examples of reduces that can be collapsed. The reason we can't collapse this reduce is there's no like trivial way. All the data that's loaded is actually used. But if you don't have a load, or if the load is like an indexing load, this reduce collapse thing will hit, and then the reduce will disappear. I can show you guys examples of that if you're interested. But so either way, before we render, we're going to remove the reduce, and the reduce is replaced here with a define ACC, an add, and an assign. So that's the ACC, that's the assign, and that's the add. What does this devectorizer do? I should label some more of these. Why is it trying to set up Wi-Fi calling? I don't know what that means. I should also rename this to not be called opts. It's kind of a bad name for it. Okay. I see final rewrite. We can look and see what final rewrite's doing here. Oh yeah, so like this is like, you see this mul 64? So that's equivalent to a shift left 6, and that's just faster. So it'll replace it with things like that. Looks like that's what that does. Then we have the linearizer. So we actually have to convert this into like a line. It creates basic blocks. And this was rewritten to be way simpler. This is actually readable now. Then we merge them together. Create one big block. How am I changing? It's just left and right arrow. And sorry, Viz needs a tutorial that explains this. Yeah, so there you go. That's the complete compilation of a kernel. You can see kernels like this are even simpler. So you're going to get the lower again, which is just going to convert the indexing to that. And maybe that is kind of the refactor we want. It's going to require annoying changes to the tests. We could put all these rewrites in one file. Is special used for anything else besides GIDX and LIDX? No, it's not. So, recursive structure, blah, 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 blah. We have to just find ways of starting to deal with this. Because it's just recursive structure all the way down. Like you're doing loops, you're determining your loop orders. tenuous a saying. It's the goal is to make the hard things easy and the impossible things hard. And that's like the goal of these refactors. That's like the theory behind how tinygrad's eventually going to work. So here you see we convert. This is a more complicated view here. You can see that this is just that view is not even really used for anything besides the valid. So let's lower it to valid. What other refactor should we do? Does a refactor mean 1.0 is far away? I mean, 1.0 is just a number. I don't know. Like, we have docs. Like, tinygrad's very usable, even though it's not 1.0, and it doesn't change that much anymore. Like, some things change, but, like, there's a lot that doesn't. Alright, so maybe we do start wanting to like just take this out into a big file called like, I used to call it flow.py. The problem is there's like tests that test a whole lot of intermediate stuff. I'm not really sure what the best way to like make this work is. Part of me kind of wants to like just create a list and then make like a multi-graph rewrite thing. Well, this is just the devectorizer still. Lower needs this also. Right, so we want to return a list of pattern matcher. Should create a data class for that. Yeah, probably. So LVM calls these passes. Okay. Doesn't really need a name. Right, so actually this should make it faster because we're like lifting out some of this like deciding logic that runs each time. The linearizer can't entirely fit into that yet either, but the lower should be able to. instead of actually running the graph rewrite, we're going to say ret equals list rewrite step ret.append pm quant none. Let's say name equals quantized. Okay, so that's if we're doing a quantization. Oh, but see, so we're gonna make this a callable. We want to take in a uop. And it can return any. Oh, so that should be PM lower. Should I require a name? I guess I don't have to. Okay. Not a big deal. Okay. Expander. Where does sim come from? Codegen symbolic, import sim. Migrate indexing is in the expander. Oh. Okay. Okay, we ran the lower, we ran the expander. Now we have to run the devectorizer. So those should actually probably be arguments to that. Whatever, we'll just call it every time for now. Okay. Probably can do like a local import there too. Just clean this up a little. They're just like different levels of devectorization. It's like not that useful. This should be refactored too. Transcendentals here too. These are like context things. Great. So let's find out where that's called, and let's see if the test will pass. Where do we run these stupid things? Things like full graph rewrite. All right, we test it in a whole lot of places. The tests are all going to be cleaning up, but it's this. Okay, basically this. Like it's basically what I want is like sequential. It's this basically. Okay, finally something that didn't work. So you see what I did? I just kind of moved all that logic out to this function. So this is a general pattern in tinygrad. What you want to do is you want to bring as much out of the you want to reduce recurring expense as much as possible. So this can like generate the rewrite steps separately from the actual application of the rewrite steps. And then the application is very simple. You guys know the song "The Best Ever Death Metal Band in Denton"? Oh, it's a great song. All right, let's look in Viz here and see what we broke. Oh, we're not doing the reduce thing anymore. Where did we used to do that? Cindy vectorizer. Oh, I just forgot that one. In ops. So all the reducers that have to have contexts can't be cached. Like eventually we'll be able to like cache so much of this and it'll be fast, but if it has a context, we can't. We want to work out like what the taxonomy of these different rewrite rules is. So some of the rewrite rules can be cached, some of them can't be cached. I just got to figure out what is what. But you see how this is building a list of all the things that need to run separate from actually running it? Like it's moving logic out of the hot path. Great. It works. That one's named flow 20. Yeah, that's the problem with not naming things. Should we just require names? We have to require names. Well, I don't like making things harder to use. No, we're going to require a name. Do it first, even. Nah. I'm never happy about this. Which one did I not name? Okay, no more flow 20. Why can't the renderer be none? Why can it be none? Legacy reasons. I don't know. Some of this stuff just probably needs to be. But yeah, okay. So that's pretty nice that we can make the code work like that. The linearizer doesn't work like this, because the linearizer has this extra step where it combines block ends. I can write that as a pattern matcher step. I also kind of don't really mind the linearizer being separate. All right, you can see how that clearly becomes that. All right. See if tests fail. One failure. What do you think our failure is? Wait, what? Really? Hmm. Okay, so that's a pushed branch. Go over here and make that a pull request. Okay, so this one surprisingly worked. Huh, and on master it doesn't work. Out of bounds access? That's strange. Oh, because I didn't keep the spec check. No, but that's in the linearizer. Wait, what? Okay, it's the same thing, just on this one it happens to work, and on this one it doesn't. So strange. Oh, maybe this context. Maybe this is because I broke the context. No, context should work. See what it says about that one. Out of bounds access. With context, ignore out of bounds 0. It's just not out of bounds there? Why is it different? Nope, failure on line 13. But we index this into that, which sure seems like a problem. But here we don't do that? Does Viz work with those? Be a little careful when you do things like that because... Oh, I should have just put Viz on a different port. Sure looks the same to me. It's all identical. What? Where's the load? Oh, the load's gone? Oh my god, what even is this? Why is that in that list and not in the other list? Alright, I should be able to use port to change. Great, now I have two vises and we can diff them. Looks the same to me, right? One. All right, there's probably just some reason that the verification isn't working. Because that looks identical, right? Why did that only go up to... Why does that one have so many more things? There's got to be some other place we're running a spec check that this is failing. Because that looks the same as that one. All right, must be another spec check in the lower. There probably is. Grouper has one. That has one. That's fine. That's fine. That's fine. Verify AST. No, that's in the tests. Verified there. But no, the test is in the linearizer. It's clearly failing in the linearizer. There's no if and stuff there, okay. I don't understand. What's different? Everyone's never verifying the one with the if and stuff. Is there something annoying in this helper test lin thing? Row 555 in the diff. I touched the linearizer. What? Well, I mean, all right, let's just try this. I didn't remove any of the code yet. fails. Totally different failure. What? What? It matters if I take that. Oh. Oh. What? Ops isn't being passed to linearize UOP? Stupid. So stupid. Yeah, that should be that. Cool. That's even cleaner. Great. That fails now. Unused imports. Wow, but that's the only one that actually validates if that spec check's running at all. Interesting. All right, now we're gonna have a bunch of tests to clean up that are calling into those intermediate things. Compatible type in assignment. I guess the renderer can't really be optional anymore. Because the lower requires a renderer, right? Yeah, okay, we'll get rid of the optional. My syntax highlighter is being slow because some of the slow ones are open. That's a fun thing to track down if you guys want to figure out why the syntax highlighter sometimes is slow. This should actually also be fine to cache. So we'll create a quick cached version of it with the context in the cache. We'll see if we can reuse that from. see if all the tests pass. So this stuff should really just be moved to be on the renderer. Like there should be a method on the renderer, right? I'd really like to make this not depend on the renderer. That'd be cool. Because now we have to go through and delete these other methods. And you're going to see there's tests that depend on them and stuff. So where is rewrite shape tracker with index used? Should we try to fit the linearizer in here? I think we can. Keep the sync around still. We don't keep the sync around. The sync actually goes in a block. Which is kind of annoying. It's not a sync anymore. So I don't even know what I would trigger on to do the block end merging. Like this combined matching block ends thing kind of can't be a rewrite rule. This can be a rewrite rule. Like this can be called something like linearize or finalize. And it can return a basic block. We can go from this, and that could be like a linearize or finalize, which puts all that stuff in. And I'm probably going to start passing args into this to turn certain things off. All right, so create blocks, that's a clean rewrite. Combine matching block ends. Can't be. Like that has to run across the whole graph. I guess I could do something special for a sync here. Does that work? That just drops the sync entirely, which I don't like. Like it'd kind of be cool to keep the sync out of it and just put all the stores in a block. It shouldn't change anything. Don't use X anywhere else, right? I'm gonna be careful with that. Should be fine. That could be a different kind of bug. I see. Yeah, it's fine. Okay, so now we can trigger the rewrite on the sync. And then we can move the linearizer. Right, so now the sync stays, which is kind of nice. Like the sync doesn't actually go in the block. Oh, bottom up needs to be a flag. that also has to be a tuple, which is like fine. Okay, that should be the same. Issue. Oh. Actually gonna run that twice, which is kind of stupid. It's a little slower. It's only a little slow, it doesn't matter that much. Yeah, that's close enough. Okay, now we can move that to flow. Cool. Okay, let's do tests. All right, we got some failures. Use of undeclared identifier ACC0. Interesting. looks like that's failing. Interesting. That doesn't look nested to me. Okay. This should be easier to see. Declared identifier ACC0. Again, oh, it's used there. That like didn't make it to the if for some reason. The end if is oh, that's stupid. Yeah, okay, that's wrong. They don't all necessarily have the same context. I knew I was writing shitty code when I wrote that. Okay, fine. right? Yeah, that's okay. I know what that is. Great. Pass. Ah, looks better. But no, we're not actually using the linearizer. I don't know. Linearizer can be optional. There's probably some places where I don't want it, but the other ones I don't know. Okay. Cool. Let's go to kernel.py. Get rid of that. Get rid of that. Change it to list. Arg list. Best ever death metal band out of Denton were a couple of guys who'd been friends since grade school. One was named Cyrus, the other was Jeff, and they practiced twice a week in Jeff's bedroom. I can get my guitar out, you know. Alright, so we got some failing tests. Let's see what we did. Transcendental crap. What? Wait, oh, did something not render? Oh, maybe because I broke something else? List sync arg list, list sync arg list. I don't know about that. Okay. Why is there a block there? That shouldn't happen. Okay, it's something to do with linearize you up, which really needs to be deleted anyway. Oh, I think that's being run with... No, it always has a sync. Where's it getting block from? I don't get it. Oh, the sync has block as a parent. Oh, that's stupid. because it's not the real sync. Ugh. I hate that. Oh, that's so annoying. No. All right. It's fine. Okay. We're just gonna need to get rid of that sync crap. Get rid of that sync crap. Get rid of that sync crap. Then here, instead of matching on that, different bug. What is that? This shit. Weird, what? Should work. It's not even running? Oh, because finalize is being called on sync. It shouldn't be. We need some way to mark this as like, we'll just use new UOP. Let's take a look here. Cool. Tests. We don't even really need the arg there. I guess it'll format less good without it, but pretty cool, right? Lower, expander, devectorizer, linearizer, all in one file. Big function to apply the rewrites. Simple. We can see which ones have context. We can print this. We can explore this. Return value expected. Oh. Happy. So we can delete all of these like other things as we start to refactor the tests. But is everyone starting to get the hang of the flow? Lower. No, I shouldn't call that move ignore. I should call that expander. So now we can kind of understand what the expander does. You see these unrolls? That basically, it's like unrolling a loop. So, and these contracts are like unrolling the loop. So it pushes those all through and turns it into a vectorized graph. See, now things are vectorized. You can see here 8, that means like it's just the same thing going in 8 times. So that's like a broadcast. We don't have a special op for broadcast, it's just vectorize. Good. That's the expander. I shouldn't call it main devectorize. I could just call it devectorize. Again, it's easier to see that now that it's all in one place. Okay, so you'll see the devectorizer is going to like blow the graph up into tons of UOPs. It basically just makes copies. It's because GPUs can't handle vector things. LLVM can though. So you don't actually need that step for LLVM, but then sometimes some optimizations are missed. So yeah, we got a big whammy there. Final rewrite does all those like shift things we were talking about. Then it runs linearizer. That's final output. Yeah, I've been thinking about flow like this for a while, but like we're finally to the point where it's clean enough to do it. That's the core of kernel creation in tinygrad. SM90A can do F32X2. What do you mean by that? Like you're saying it's got like a dual ALU? I mean, yeah, but maybe. See if you can get things to go faster. Well, I mean, the first thing to really like fix is to make the warp vectorized. And then the defactorizer is going to get fancier. But yeah. RDNA 3 actually has a dual ALU. But so the dual ALU is not actually where you want to put that D type generally. Because a lot of the dual ALUs have requirements on register banking. Okay. So now, shall we start deleting these functions and seeing what tests break? Well, first let's see if all the tests pass. All the tests pass except unit tests, which is because of line count, which is fine. I say we bump the line count, and then we'll refactor the test later. That stuff didn't get committed? What? Oh, I guess the test passed without the linearizer, I say. So that actually didn't get committed. I'm also just going to clean this up. How much faster is this all going to run when I refactor this? RTX Blackwell. Oh, we should run GPU burn on this. We ordered the new power supplies, but I didn't actually test them. Args for this. Use tensor cores. Let's go for that much. Go. Damn, that's a lot of watts. GPU fryer? I haven't heard of this one. Interesting. Try it. It's hot in the room now, so the GPUs are going to get a little hotter than usual. It's really hot in that room. Should I use Rust up or should I just apt install cargo? All right, let's just trust Ubuntu. one's getting hot. Thanks, Hugging Face. Why am I trusting Hugging Face? Okay. I'm not using snaps. Are people supposed to just know this? Sounds good. Yeah, okay, let's go. Great, we have yet another package manager. Yeah, 81's too hot. We should look into why that's happening. I mean, I can crank the fans. Oh, it doesn't work on this box. I mean, 80's okay. This isn't throttling yet. All right. Related to the rewrite of what is tinygrad? Where have you been? Oh good, it's cooling down. Alright, you want to try GPU fryer instead? Oh, cool. It tells you if it's throttling. Oh, that's nice. Wait, this tool's better. Yeah. Look at all those G-flops. I don't like that that one's hot. We got to figure out which GPU that is and fix that. So this is a prototype of the tinybox V2. Oh, but that's so cool that it detects throttling just by doing matmos. No one on here? Let's GPU fry this guy too. Right, so can I just do that? Maybe that works. All GPUs seem healthy. Fry longer! I'll use the stupid how they say to install it. Because this one has a different Ubuntu on it. Oh, we gotta try messing with the peer-to-peer hack on this too. Like, these are all the things that have to get done for what? Cool. This is why I stream. I appreciate you. Yeah, the tinybox is sick, and trust me, we're not going to hit 80. I promise we're not going to hit 80 on the shipping box. I got to fix this. Like, what you got to figure out, we got to move the GPUs around until that doesn't happen. 78 is really what I consider the max, but they're not throttling. Or like, guys, these boxes, you know, there's someone who built like a competitor tinybox. If they don't know anything about machine learning, they're not going to build a good box. We've put so much effort into this shit. Like, we use these. Comma uses these. So this is a old tinybox screen, also in a very hot environment. It's freeing GPUs. Definitely 360. Yeah, it's not the end of the world. But look at that shit. It's a lot of power. Oh, I'd bring you in there. I'd bring you in there. We could go look at them all. I don't have a good way. Yeah, it costs double the price for half the power with shit software. The tiny boxes are amazing. Like I said, if you order a tinybox red, I will ship it to you Monday. These are for sale. We have our own drivers for them built into tinygrad, which are actually very good. Yeah, tinybox red ready to ship. The pros, unless we find out a way to get 4090, so we had to sign all this stuff for the 5090, so I don't think there's going to be a Pro 2. I don't know how much NVIDIA loves that, but I know NVIDIA is cool with that. So, you know, we don't want to lose our lose the plug. It's at 81 too. Well, this isn't a super hot environment. Like, the intake here is like 35. We run our data center hot. Sorry, our compute cluster, not our data center. I would never put a consumer GPU in a data center. Only in a compute cluster. That's hitting 83. Crank the fans. This one, this will actually work on. I don't know what it is for the new box yet. See it come down. There we go. So yeah, if you're going to run them in a hot environment, you have to crank the fans. But if you're running them in an office at like a normal office temperature, you don't have to do that. And the fans still aren't loud. They're Noctuas. Probably some kernel driver I need to load. No, I don't think it's a kernel driver. I just need to find the... Well, we're just going to fix the hotspot. I mean, it should be even easier because there's only 4 GPUs in there to cool. So I know they draw a bit more power, but... yeah. Yeah, so if you want to buy a green V2, the 5090s are here. 5090s are here. I have enough 5090s to build 11 of these. So if you're buying, we shouldn't say usually ready in 2 to 4 days because it's not. It's a full money pre-order. How many dB are the fans? They're the 120s. No, they're the gray ones. It's this. Yeah, it's 9 of those. So 25. Not times 9, but you know, log times 9. Log sum exp. And it still has the GPUs are like the normal gaming variety with the 3 fans. Yeah, okay, there you go. I'm happy with those temperatures. I mean, those temperatures aren't bad, but we'll just move the hotspot a little bit. This one can get 5 degrees hotter, and this one can get 5 degrees cooler. I'll figure out how to do that. Um, 32 cores, 192 gigs of RAM. The RAM's super fast. Should actually start testing that stuff because it's not as fast as I thought it was. AMD cheaps out on the non-highest end epics. All right, let's see. What tests are failing? No. Process replays failing. Why is process replay failing? Oh, process replay. Okay, that's fine. That's only failing because I created a new UOP. Let's push up to master. Let me rebase that on master, pull that, and it should be good to merge. AWS runs. Yeah, I mean, you want to run things hot. There's all sorts of reasons you want to. Cool. No throttle. This isn't good throttle either. It's kind of leveled out. But yeah, who is buying a tinybox green V2? We have 9 more cases to build pros. If someone wants to buy like 9 of them and has 4090s, I'll build them for you at a good price. But it has to be a certain 4090 too. Comma used a whole bunch of these. Let's update that branch. The problem is if you change the UOPS, process replay breaks. So we can, because it serializes it based on the numbers. All right. If we're asking about chair, that means it's kind of the end of the stream. Are there any questions from non-subscribers that are good? You don't need to watch me clean up tests. That's pretty boring. Yeah, we can go around now and start deleting all the stuff that's not in flow. Like all like rewrite shape tracker with index, full graph rewrite, linearizer. Yeah, just clean up some of the tests. Will I ever make the tinygrad tutorials more addictive? Can I explain the different UOPs? I mean, like, which UOP do you not understand? Which UOP do you want an explanation of? Which UOP's like, wow, that UOP's so confusing. I need an explanation of that UOP. The Qualcomm DSP simulator? Dude, not only does the Qualcomm DSP simulator work, the whole thing works. We got a contract for that. There's a branch where the whole thing is faster than SNPE. So yeah, no, we have a simulator. It's all tested. Yeah, if you go to the repo, you can see that not only do we have a simulator, we have that all working in CI. So go here and go to DSP. Did I change the room? This is my office. My office in San Diego. Yeah, so which UOP you want an explanation of? Mod? Mul? Add? Special? I mean, special is just the stupid indexes from the GPUs. vconst is just like vectorized constant, 0,1. Unroll is a little confusing, but you really understand what it does after you see it go through the expander. So you can watch unrolls turn into vectorizes, and then vectorize is just like the D type. It's just like a wider, like, you can see what like add vec32 is. It adds these constants to that value and then probably shoves that into an index somewhere. We process the indexes into groups down here. Devectorize. What's the purpose of this UI? I mean, like, do you know how compilers work? Need to advertise? No. See, we only make we don't make products for spiritual bottoms, you know. We make products for spiritual tops. Just turns out that 90% of the world just wants to be spoon-fed garbage, and you can't fix that. It doesn't matter who buys. Yeah, but like it does. You just want a GPT wrapper? Yeah, just go buy the cloud from DeepSeek. If you're okay with being, never mind. I'm not even gonna that's not even making a sales pitch. Like, sales is stupid. It's just, you know, like, I guess what I'm not going to do is I'm not going to try to convince you why you want GPUs in your house. If you don't understand why you want GPUs in your house, then this product's just not for you. If you understand why you want GPUs in your house, and you want GPUs in your house, and you're thinking of buying from somebody else or building yourself, you should be buying a tinybox. So yeah, I guess that's the only person I'd consider like quote unquote marketing to. I mean, if you're buying from somebody else, we're just way cheaper and better tested than everybody. Like, unless you're buying like super high end data center stuff, then probably not. But yeah, if you're thinking about getting like gaming machines or something, and like putting multiple GPUs in them, you're gonna have such a nightmare doing that. Like, you see how janky all the builds look. You can look on like Local Llama and see the people who are doing builds. You can probably save 30% of the money. People are like, I added up the parts. It's 50% of the money. No, it's not. You just forgot the hard parts. What PCIe extenders did you use? Well, I found these ones on Amazon for $30. Yeah, they don't work. Check out Deep Wiki for tinygrad. Yeah, it like looks kind of right. I saw someone linked that on Twitter. What? Is this the website? Why doesn't it work? There we go. Okay, ready for the noob intro to tinygrad? Tinygrad is a deep learning framework designed with a simplicity and extensibility as its core principles. It aims to position itself. This is wrong. This is wrong. It's just as full-featured as PyTorch. Yeah, that's mostly true. Okay. Simplicity, extensibility, performance, compatibility. Yeah, okay, that sounds good. This is good design principles. Great. Great. At the heart of the tinygrad is the tensor class. Yeah, that all sounds right. So yeah, tensors, and you can like do shit with them. Yeah, that's good. That's good. And then you got like ops that are uops that are underneath the tensors. Everything's lazy. That's right. And like, yeah, this is like the pipeline that it goes through, like mostly tensors. It's lazy. You create a schedule, and then you create the kernels, and then you execute the kernels, and then you get a result. Yeah, so that's how scheduling works. What we were working on was compilation. So like to compare like what these things are saying here is like, when this thing talks about scheduling, this is scheduling. And when this thing talks about compilation, this is the compilation for each kernel. tinygrad supports a whole bunch of hardware. Like there's things that we support crazy well, like nobody even advertises, like WebGPU. A bunch of people now are like using this as their way to get neural networks in the JavaScript. Yeah. I think we also even support, if you do like -m tinygrad device, right? So this shows you like all the devices that work on your stuff. So like Metalworks, no AMD, all three interfaces of AMD don't work. NV doesn't work, CUDA doesn't work, Qualcomm doesn't work. This is the Qualcomm GPU. GPU, CPU, and LVM all work. DSP doesn't work, and WebGPU works. So you can run that. If you've installed tinygrad on your computer, try this right now. Python 3-m tinygrad device, and it'll show you what devices are available on your computer. I'm going to push this to update benchmark. Update benchmark is only accessible internally, and it runs our stuff on the on our internal CI boxes. So if you watch that pull request, you can see what I just did. Yeah, we have optimizers and shit, and everything's like efficient, and like we support all the models, and yeah, it sounds good. Whoa. How D-types work. Wow. Well, that's cool. It built this promotion lattice for us. Can you see the servers? I don't really know how to move the camera over there. Yeah, so like that's a UOP. Some methods on UOPs. Pretty cool. Oh yeah, I can do all the graph stuff too. Oh. Like, this is a full AMD driver. This project is... The scope of tinygrad is massive. Despite it being tiny. Despite it only being like that many lines, it's kind of like... It's kind of like an operating system. And LLVM combined. Your 6650 XT only has GPU and LLVM. What's the YouTube link? You gotta tell me what the YouTube link is before I click it. I'm not getting rickrolled today. We'll click it, whatever. You're a subscriber. Oh, Mojo? You duped me into bringing up Mojo. Is it open source? If it's not open source, is it open source? But like, is it actually open source? No, like it's the modular don't build a platform, build a library. The problem with this stuff is like you're almost worse NVIDIA. Do I think MLIR is a solution? No. I think MLIR is fine. MLIR is not bad. MLIR is a lot better than modular. But like, similarly to modular, it's like, what exactly is MLIR? First off, do you know the ML and MLIR doesn't stand for machine learning? It stands for mid-level. And it's this like hierarchical, like you can write rewrite rules. In a lot of ways, it's similar to tinygrad. It's just a lot more complicated. And you have to sit there and recompile C++ rewrite rules for things. Multi-level, yeah, that's it. Multi-level, not even mid-level. I'm wrong. I'm just thinking of mid-level because I'm Hong Kong, but so yeah, I think that like this falls more into, I mean, I don't know. I mean, is it open source now? Like, it's hard to tell what's open source and what's not open source. The core modules are open source. But is the runtime open source, or do you expect me to like send it to your closed source platform? Yeah, you can probably write code for most future robotics use cases in very few lines of code with very low dependencies. That's kind of the idea. Right. Again, these projects are not one-year things. These projects are lifetime things. This is going to be the operating system for life. I don't know. Maybe we could do a stream where we play with it, but also like, is it fast? Well, I'm not even exactly sure what it can do. Like it's Python? Can it generate fast? Like, is it competitive with Triton? Like tinygrad's not competitive with Triton. Triton is beating us. There's a few features we have to implement in order to be competitive with Triton, and we will implement them this year, and then we'll be speed competitive with PyTorch and NVIDIA. Very notably, the one that we're missing is, no, look, and I don't need to hate on modular. I don't exactly understand what it is, and what it can do for me, and what's open source. Like, in many ways, it's the same thing. tinygrad is this as well. We don't exactly have batching and stuff yet, but this is our cloud front end we're going to work on. Chris Latner is very smart, and I'm sure he has many of these same ideas, and, may the best implementation win. The video goes into detail. You think I'll like the video. I don't know. The stuff being not open source just rubs me the wrong way. Okay. No. No, we're not compiling to MLIR. I don't even want it. Like, we use LLVM now. tinygrad replaces MLIR. We still use LLVM, which MLIR does as well. But I'd even like to replace LLVM. Like, just look at how much simpler all this stuff is than, like, the usual compiler flow. Like, try to read Clang and LLVM. They're so complex. I mean, this stuff like looks complex in a first glance, but only because it's all laid out to you like this. When you actually dive into each one of these things, you're like, oh, it's like actually very simple. And the whole workflow is here. Once you understand this, if you understood each one of these passes, and you totally can, you understand all of tinygrad. Yeah, see, this is what I mean. Closed source binary is distributed under the proprietary modular community license. They've committed to open sourcing it in 2026. Yeah, they do not include the compiler or the runtime. Yeah. Okay, check back in 2026. Wait, SNPE killed TF Lite and TF Mobile? Yeah, and then tinygrad killed SNPE was so broken that comma no longer runs the driver monitoring model on the DSP because Qualcomm broke SNPE for the old versions of the DSP. And there's no way to even download the old version. It works with like Python 3.6. We're like, no one's dealing with this anymore. Yeah. So, no more of that. All right, I gotta eat food that's not seaweed. It is seaweed. All right. We got anything else? Oh, we got a lot of viewers now. 531. That's pretty good. We'll see where XOLab goes. I don't think those Macs are the best choice for much. I mean, Apple has very high margins on their hardware, and they've realized something good, which is that you should be using LPDDR. Like, when we build accelerators, I'd like to use LPDDR. Not GDDR, it's too power hungry, and not HBM, it's too expensive. But, yeah, overall, the idea of, like, buying Apple hardware to run models is, like, not a thing. Like, it's a thing for hobbyists. It's not what's my take on Qualcomm as a company? I think they're getting better. They need to sell their chips. Like, one of the coolest chips on the market right now is this. And if Comma was building now, we would not use Qualcomm. We would just use this chip. Like, there's no reason we should spend time with Qualcomm when this chip's available. So, you know, I'm bullish on, like, the Chinese are just so much easier to work with. Qualcomm's a huge pain to work with. And it's not because their, like, chip is bad. It's because their sales guys are like, like the guys like from the 80s who like, their glory days was like doing coke and selling chips to Atari. Like, get those guys out of your company. The Chinese don't have this. The Chinese are like, I want to buy a chip. Okay, how many pieces? Qualcomm's like, I want to buy a chip. Oh, hey, you want to take this guy to lunch next week? Take this guy to lunch next week. He could use a lunch. Got time for lunch? I'm trying to buy a fucking chip. No, Qualcomm also has a shitty patent division. Like, here's another thing. You want to see, the US needs to give up intellectual property. Intellectual property is like, it's the worst idea since tariffs. It's just tariffs. Intel? No, Intel is... You see my blog post on that? The tragic case of Intel AI. No, they're impossible to work with. Like, AMD got some hate, but they were fine. Like, AMD's... They're getting it. They're getting it. They're a little slow, but they're getting it. Like, I have a lot of faith in AMD in the future. NVIDIA, come and go. They were easy to work with, and they got rich, and they were hard to work with, and now they're a bit easier to work with. They're still overpriced. Yeah, well, you see, we need MSA first, then we got to go for lunch, followed by 2 dinners we get absolutely blitzed at, then I'll go hit on some women half my age, even though I have a wife and children. After that, you can buy some chips, but we're going to need to sell you support at 15% of your hardware purchase price. Exactly this shit. Exactly this shit. I can't wait till, like, yeah, fuck Trump, fuck the tariffs, because it just keeps uncompetitive shit like this around. I can't wait till the Chinese show up and just blow all these people away. Competitively in a merit-based market. And hey, you know what? I shouldn't say fuck Trump. Trump can turn it around. Get rid of the stupid tariffs, fire your tariff guys, and be like, oh, I was wrong. Hey, tariffs suck. We like numbers going up. And everyone will love Trump again. Copyright should have died when Napster came out. Exactly. Exactly. Like, oh my God, intellectual property. No, you can't build a log cabin. I built a log cabin first. Well, I didn't vote, so joke's on you. I was happy Trump won, but now Kamlala might not have done this. So I don't know. China at the top level has common sense? Yeah. I think I said that before the election. What I really would have done was written in Xi Jinping. I did not. I voted for him in 2016. I didn't vote in 2024. I was in Hong Kong. I would have voted Trump. But I just didn't expect it to be this dumb. How do you protect expensive R&D if not with IPs? Like, oh my God, like this is the mentality problem. Like, don't be like, I R&D'd this idea. Okay, execute better. You don't need IP to just execute better. Be the first person to ship it. The only thing IP gets you is a moat. You don't need a moat. Just continually execute better. And if you can't do that, you deserve to lose. I'm sorry. Oh yeah, his nickname in China, yeah, he's like Empire Builder Donnie, because he builds the Chinese empire. Oh, the Chinese love this shit too. Like, can you ask for the better, like everyone in that region? No one's a huge fan of China. Maybe like Singapore's a huge fan of dealing with the Chinese. But now US slaps a tariff on Singapore, and suddenly Singapore's like, hey, the Chinese, no tariffs there. No, what do you mean? Trump term 1 was a right. Trump term one was good. I'm much happier with Trump and Trump term one than Hillary Clinton. I think in Trump term one, two things that I liked. One was that there weren't wars. Like Hillary Clinton would have started all those wars early. She loves wars. And the other thing I liked was there was a meaningful decrease in regulation. You know, the Obama administration had this like 130-page thing about self-driving cars mandating like data collection formats and just ridiculous things. And then the Trump initiative came in and they replaced it with a 20-page thing that said self-driving cars are good, especially American self-driving cars. And I'm like, all right, great, I love that. So no, Trump term one was good. I just didn't realize that, you know, there was time to go full retard in term two. Yeah, but like putting tariffs and doing what he did is very different. I'm not even truly opposed to like a smart plan to bring manufacturing back to America, potentially through some long-term implementation of tariffs. If you want to get things out of China, like there are reasonable ways to do this. I wasn't like, there was a 25% tariff on China. I didn't really support it, but I wasn't that opposed to it. Like I understood the point. But this is nonsense. The COVID thing, I mean, you can say Trump sucked at COVID, but who did better? Like, overall, I think that, yeah, maybe he could have used, I don't know. Like, it wasn't, it was fine, especially compared to some other countries. No, the problem, he reread Art of the Deal, and in Art of the Deal, it says you want to maximize uncertainty. And, like, that's fine if you're trying to, like, you know, scam, like, pawn off your scam casino on somebody. But that's not fine if everybody else in the economy depends on you. Uncertainty is bad for investment. I mean, that is the problem. It's not a spectrum problem. I've met smart left-wing people and smart right-wing people. It turns out we always just seem to get idiots. And like, it's not even generally Trump. It's these people who he listens to. Like, where does he even find these people? Look at all the investors that are investing in US. They kissed the ring. Oh. No, but like, you say he didn't do anything great the first year. Yeah, but you have to also think about all the things that didn't happen. No IP is probably better for society, but more stressful and competitive. We got to do it for the love of the game. No resting on laurels or chilling on a yacht. Exactly. Yeah, and in the 80s, against Japan, tariffs might have made sense. Now, against China, they're nonsense. Also, like, again, if your goal is to move manufacturing out of China and to nations that are more friendly, like Vietnam, I get it. If your goal is to also tariff Vietnam, like, that's where the whole thing lost me. This isn't even a good anti-China move. You put a tariff on Singapore. He put a tariff on Singapore. We have a trade surplus with Singapore. Singapore has completely free trade, freest trade in the world. Why is there a tariff on Singapore? If the goal is to destroy America, it all makes sense, yeah. If the resentment has built up so much that the hatred for the globalists is so strong that, you know, you'd rather take it down with them, yeah, that's one explanation. Yeah, fuck degrowth. Like, I hate this. Why isn't there growth? Where are the growth people? The goal was to dip and buy the market? Great. I mean, yeah, he did make a shitcoin. Like, yeah, you can have it all, my empire of dirt. He made the Melania one too. Yeah, you know what? This shit was all funny until the economy went like that. And I really don't think people know how bad it's going to get. Musk hates Trump the most, but can't say it publicly. Yeah, I know. Right? Like, you're Elon, you're pissed as hell about this. Okay, what do you do? I don't think turning against him right now is a good idea. Am I not concerned about climate change? I mean, sure. I'm concerned about, like, pumping CO2 into the atmosphere. Okay, let's fix that shit. I don't want to hear about degrowth. I want to hear about importing massive cheap solar panels from China. Like, yeah, let's stop generating power using coal. Great idea. I like this. Can we use nuclear and solar? Love it. And wait a couple more months. Yeah, like, I'm here. It's not like I get a choice. We're all strapped in the clown car together. Someone told Trump he can't do tariffs. So you know what? You know what? I will say this. As much as the tariffs like are awful and mess with me, at least we can all have a good time and laugh about it, right? Like, the lulz are still there. So, You gotta appreciate lulz. All right. Do we have anything else to discuss? Everyone go install tinygrad, use Viz, check what devices are supported on your computer. Great. Let's merge what we just did. YOLO. All right, now I get to spend the whole day doing shitty refactors of the tests. In fact, unless you guys want to do them. Oh, can I trust you to do them? Do you want to delete all those functions we replaced? Oh, that'd be so cool. That would let me know you guys are paying attention and make me so happy that I do streams. We did learn about GPU hugging facer today, or whatever it's called. GPU fryer, yeah. We learned about GPU fryer today, so that was good. Yeah, here's what I want y'all to do, okay? So you see this like function, replace shape tracker with index? It's not called in the main code base anymore. So remove it. See this function, expand, rewrite, and you can just do one function. You don't have to do them all. We can remove that one too. And you see the linearize function? We can remove the linearize function too. Like, see this function, linearize you up, delete that. Yeah, you guys can do it. I believe. Please do it cleanly. If you submit AI junk, I know your AI junk. I will delete your AI junk. Seaweed. We can connect GPU over USB. All the USB stuff's now merged. So it should even kind of work. I haven't really tested it yet. But yeah, there's a USB driver now in the AMD GPU. So we can drive an AMD GPU over USB. I did just merge the stream stuff. Oh, you see the Turing test was passed? Yeah. They did fine tunes on it. called Persona. And the GPT-5 fine-tune outperforms, it's more human than humans. Oh, GPU over USB? Yeah, I know, it's crazy. Yeah, how do you think we're going to get lots of compute to the comma? Right, the commas have USB ports. That's a USB port. So you can just plug a GPU in there, and then your comma is going to use the big GPU. Is there really a plan to sell comma with consumer-grade GPUs? Yes. Oh no, what if it breaks? Okay, it'll fall back to the model on the device seamlessly and beep. Like, there's no problems with this. And then if everything fails, it beeps. Like it's a level 2 system. But yeah, no, and actually, I don't even really want to like try to profit off the consumer grade GPUs. You can use any standard GPU enclosure. And it'll work with like any GPU that's like better than a certain GPU, and you'll just plug it in and it'll just work. And we'll probably offer like a whitelisted good explanation, but no, 980 sucks. No, you can't use a 980. The minimum NVIDIA card that even works with our driver is 2080. Yeah, now you'll have to upgrade the GPU in your car as well as the comma. That's right. Ooh. All right, I gotta get food. What do I want today? Pizza? Do I want pizza? No, you don't. You put the GPU enclosure under your car. What food do I want? I wish I knew which pizzas I liked. I order different pizzas, and sometimes I like them, and sometimes I don't. This one's pretty good. I'll be here fast. Specialty pizza. No. North Park Pizza. Tomato sauce, mozzarella, pepperoni, sausage, jalapeno, extra virgin olive oil. Perfect. Not paying extra for gluten-free crust. Why would anyone do that? Unless you have a gluten intolerance, and we have to be tolerant of others with intolerances. Ooh, when does the new rehearsal come out? I'm excited for that. Yeah, it's a Samsung Fold. Z Fold 5. It is a Trailer Park Boys reference. Thank you, game player, for understanding me. I feel seen. It's a thinnish crust pizza. I think this might be the place that also inexplicably makes Philly cheesesteaks. It's like a weird San Diego thing, you know? Red Lobster. Yeah. I went to Red Lobster once. Pretty good. And I talked with this girl at the bar about Andrew Huberman. RIP Samsung CEO. Wait, is the Samsung CEO out? No. RIP. Yeah, he could have run Harvard. He could have turned that around. Oh, by the way, the Comet 3Xs are on sale, so it's a good time to buy them. And it's actually like people think, oh, it's on sale because they have new hardware planned. Like, there's new hardware planned, but not anytime soon. This is just because production is now a lot more efficient. They like refactored production. I see the production numbers are like way up here. I don't know what happened. I haven't been here for a few months, so I'm still catching up with everything. But yeah, no, buy a comma 3x. And you know, you won't be limited by the compute because we got a USB port. I don't know if any of that's gonna work. We'll see. Hopefully it'll work. Why am I not building it in China? Because we build it in America. Okay? I invested it because we build it in America. Okay? Because I like touching the shit that builds things. Okay? Some of the tests use rewrite shape tracker with index. Yeah, I know. That's what you have to refactor. So just refactor all the tests to call into get rewrites for renderer. Oh, that function's beautiful. Got to fix that to not need opt. That'd be a nice refactor. Also, the other refactor that I want is, so like, you shouldn't have to call this every time. Or at least this should be cached, but you have to cache it with these 3 context variables in the... Yeah, we can just do that now. You want to do that? Should be a way to do like context dependent cache. Then they would use all the other rewriters. Yeah, but see if that's a problem. It might not be a problem. Oh, that's wrong. But yeah, that's great if that's all cached. In fact, probably if that's all cached, nah, whatever. I'll leave it like that, but. No, I've never had a problem with the cops. I've gotten pulled over multiple times with it. No one cares. The laws are really ambiguously written about things like that. I don't know, maybe in some states, but all I can say is anecdotally, I've never had a problem. Because these are like global context variables. And it's great to like reduce the number of, so how many is this? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 rewrite steps. So I used to have this thing. This one's going to need to be fixed. External benchmark schedule. Wait, what? It doesn't even work anymore? Why is all that printing? What? What's triggering that print? I don't even know. Did I leave crap in there that prints them? Oh, God. Can't believe I pushed that to master. Because I didn't carefully read my diff because I was streaming with you guys. If I carefully read my diff, that never would have happened. It's your fault. It's never your fault. It's always my fault. I chose to stream today. And I own my choices. Okay, so like lower, rewrite, and linearize aren't gonna work anymore as separate steps. Great. Okay, now that shows how long each kernel takes. The prep is very fast. The rewrite includes a linearizer. Wait, what? Why is it so fast now? Oh. Did I check if that's like true or something? Wait, that's still fast. Oh, because I'm running with linearized 0. What? Cool. Great. Process replay detected change. I didn't do that wrong, did I? Oh, that's not a bool. These are just wrong. I don't know why I put types there. I mean, I'm not sure that matters, but still. Probably want to get the value of those because it's not. Yeah. No, because if I wrote it in OCaml, nobody could read it. 6 Jane Street engineers. My food is coming. Yo, bro, you ever think of rewriting it in Rust? Is Rust a foreign programming language? There might be tariffs on Rust. I don't know if you've checked. Oh, look at how slow that one is. That one's so slow. So if like you want to see what's slow, you can run with track match stats equals 2, and that'll show you all the rewrite rules and what's slow. All right, well, of course finalize is going to be slow. That's what's doing all the spec checks. Now, you liked me doing Rust? Yeah, the prep is fast, schedules are slow, ops are slow, but rewrite's mad slow. Flow. Oh, you learned something. That's good. Sometimes a side effect of the streams. I don't test on NVIDIA. I only tested it on yeah, but like you wonder with those Rust frameworks, like a lot of these frameworks are just, at what point is it not its own framework? Right? At what point is it just a wrapper around other frameworks such that it's not its own framework? I gotta go get my food. Do we want to keep going? You think about it. You think about whether we want to keep going. And if you have good things to say when I come back, we'll keep going. Just right outside. I'll be right back. right. We got a pizza. I see complaints about the font size. Oh, you want to react? What do y'all think? We like this pizza? Pizza review. Is it good pizza in China? I'm calling it some good pizza. Mainland? I don't know if I've ever really had pizza mainland. It's called a Pizza Hut. There's 0 olives on this pizza. My 10K a day startup review service? Yeah, we've gotten 2 bites on that. And we sell about a phone call a month. If you drop out of college and only study tinygrad, I mean, it depends. If you actually have the self-discipline to do that, you'll learn more than you would in college. This is $18. Making the pizza visible. Rated out of 10, 7. San Diego food is like 30% cheaper than New York. All my buddies just GPT all the assignments. Well, the thing about tinygrad is you can't GPT it. Like, what do I always say about this kind of shit? It's like, you know, all right, I'll tell you a story. I used to go on a lot of dates. And I still do, but I used to too. And people would have problems in their life. My mom's a therapist, so, you know, it runs in the family to listen to people's problems. And I would hear people's problems. And it was always to me very obvious what the solution to their problems was. And I would tell them this, and they'd never actually do it. And then I heard Morgan Freeman summarize this in a way better way than I ever could. There's an interview between Don Lemon and Morgan Freeman. And Don Lemon is the CNN race baiter guy, and Morgan Freeman is, Don Lemon is like, oh, you know about like the plight of black people in America, man. It's really terrible. And Morgan Freeman's like, yeah, it's really terrible. It's like they're so disadvantaged. They can't get out of the hood. Morgan Freeman's like, well, no, but they can get out of the hood. You see, no. See, the bus runs every day. What do you mean? Yeah, bus runs every day. It's $2.50. Yeah, but, no buts. Get on the bus. You're stuck in the hood. There's people holding you down. There's whatever. Should I do this? Should I do that? Get on the bus. But they don't. They don't get on the bus because they're just not bus getter-oners. 95% of the world is just not bus getter-oners. And you can't fix that. You're either a bus getter-oner or you're not. And I think most of you probably just aren't. So you can ask me for advice. You could be like, what should I do with this? What should I do with this? You won't get on the bus. You can agree that getting on the bus is the right thing to do. You could agree that getting on the bus gets you out of the hood. But you don't do it because you're not a bus getter oner. It's just not your nature. So that's what I feel about people asking for advice. You're not going to change your life. You're working on the x86 backend. That's extremely hard. The problem is, like, and we've had people do x86 backends, but there's so much, like, there's so much real prereq work that needs to kind of go into that. Oh, if it's locked to you, then you know what the problem is. And the problem is that it's too slow. Okay. You're going to meet the speed? 01? Sweet. The location of, what do you mean by spill fill? MI300X is submitted to MLPerf. And there's not a direct RISC-V backend, but you can just use LVM or Clang. So it'll work on RISC-V. Oh, it's so fast with no opt. Oh, OpenCL's still there, of course. It's called GPU. Oh, does someone want to do that? We should really rename GPU to OpenCL or OCL. Look how fast it is when you don't do the optimizer. Yes, Vitalik referenced tinygrad. What if one person actually would get on the bus because of me? Isn't that awesome? No, it's just who you are. You're either a bus getter on or you're not. You can't change it. It's who you've been your whole life. Okay. Maybe 1 in 100 people can change it. But that doesn't matter. Right? Like I'm not about that, like, oh well, if it saves one grandma's life, it's okay if we dunk the Dow. It's likely a question of neurophysiology. Yeah, it might be. I smoked a lot of weed too, man. That's just that's something, that's like a story that you tell yourself, you know? You were lazy before you smoked the weed, probably, too. But now you have an excuse. No, fast enum's fine. Not really. Like, most of the things done to make Python fast look more like algorithmic improvements. Fast enum maybe is an exception to that, but like it's not many lines and it's not hard to, it doesn't make coding any harder. Like you never have to think about fast enum. It's locally scoped. So like I recently wrote a compiler for the rules. I wrote a compiler for the UPATs that made the matching speed a lot faster. And like, yeah, that one is, you'd never do that in Rust or something because it's fast. But it would be even faster if you had the matching compiler. I kind of think that software just is as slow as people will tolerate. And it doesn't really matter what language you code in them. Psycho-cybernetics? No. But then you're not getting on the bus anymore. Yeah, if everyone gets on the bus, sure, you get on the bus. But then it's not the bus. Then it's not getting on the bus that's the bus, right? Wait, what do you mean? Algorithmic improvements are not nerfed by the lang. And the slowness of Python forces you to write good algorithms. Yeah, you're missing out. There's a pizza eating stream now. Have you been on the bus when everyone else is? You're just going to another hood. Yeah, that's true. That's true. I like that. Programmers should have done a better job of gatekeeping software dev. Yeah, I agree. You can see why the slow ones are slow. Look at how much yellow they have in them. I think if we devectorize equals 2, we get something else. That's even faster. Yes. Sometime we do mukbang. Oh, good. The test pass. We can push. I'm going to read the diff this time. Wouldn't need to use an LLM. You're missing the point. I'm on Roy Lee's side. You know that. LLMs are not cheating. There's no such thing as cheating. No, we don't do vibe coding because it sucks. All right. Vibe coding guy, you're the reason only subscribers can talk. Roylee's building a cloud house is what I heard. All right. I'm waiting on your PRs to clean up all those unused functions now that are only used in the tests. Oh, get rewrite for renderer. It's beautiful. All right, why is it so slow? Are any of these duplicates? Yeah. All right. Oh no. That was kind of the main refactor I wanted to do for the stream. Like, that's the whole rewrite. In one easy to reason about place. I think this works with Viz. It doesn't. Only the schedule shows up in Viz. Because those aren't tracked rewrites. Let me fix that. This whole kernel class needs to be deleted. What? I can trust you guys to do this project, right? Model prep is fast. Just slow as that can fit on cache. Wow, that cache, does that cache even work? It works. It's just a really fast function. I might rename flow to a knit. Actually, we can even put render in a rewrite rule. That'd kind of just be stupid though. Then like the source would be like the output. Delete that. Delete that. I don't know why that's in lower. This should move to quant. After you guys delete all the stuff, if you want to move this to quantize.py, that shouldn't be in the lower. I don't exactly know why those are in the lower either. Those should probably be in shape. Like shape utils or something. What does that take in? Yeah, maybe like shape util. These need types. Wow, AMD's gotten big. This file is all trash now. Now that we've moved heuristic out to heuristic, that's awful that that takes in kernel. All the tensor core stuff is here. Oh yeah, that needs to become rewrite rules. Yeah, okay, so the rewrite of this will go with the redoing of warps. Multi needs to be cleaned up a lot. I mean, this stuff's all probably mostly fine, but yeah, there's a bunch of cleanups to do there. Realize should become graph rewrite stuff. Search needs to like tack things on. Grouper's fine. Sort of. Not really. None of this code's fine. Everything needs to be deleted. These need to be moved in here. The front ends need to be moved in here. Onyx is probably pretty close. No, it's not real. Wait, so this is all that's left for Onyx? Oh, it's great. There's a bonus for George Hotz when he does this. You got to get this moved in. I don't understand why those have to be there. Wait, what do you mean? We have bitwise end and bitwise. Oh. How is that stuff right? How is that right for that, but not for those? I think we have a pretty good test for this. Yeah. But yeah. This needs to go to front end Onyx. We also have a whole torch front end too. Or back end, I don't know what to call it. It's like something. No, that needs a lot more cleanup before it's ready to merge. But Onyx is kind of close. Then we have all the runtimes here. It's all pretty nicely refactored. The null runtime. Null is my favorite. It's super fast. Shape tracker. I just touched this stuff up. I don't know if that should be there. Views. Here's the code for viz. Pretty short. There's a few HTML files. A little bit of JavaScript. Not too much though. It doesn't count toward the line limit. It should count toward the line limit. Oh, we need to make the JavaScript count. Quasland, we need to make the JavaScript count toward the line limit. Devices. Well, okay. I mean, I guess it's fine. It's a lot of stuff. Buffer, allocators. It kind of makes sense to put that in device. It's okay. This stuff's kind of gotten out of control. SQTT should not be referenced here. D-type. D-type's mostly fine. We now have all sorts of crap for FP8. Which, whatever. Here's the gradient. This was a huge win. We used to have this terrible thing with forwards and backward passes. Now it's just a transformation on the graph. It's really nice. Like our whole AutoGrad library is that many lines. I'm very proud of that one. Helpers is just some helpers. Here's a whole TQDM. Meh. Oh. Although this should happen. I don't understand why those can't all go on it's just like people are just lazy. Like there shouldn't be a simple math trait anymore. We should just have math trait. What's math trait? It's crap. These should all be moved in here because the new backward's done. These are all the different ops. Some of them mean stuff, some of them don't. Sets of groups of ops. Devices that support views. It's like notably just not Qualcomm. That shouldn't be there. That should be on the device. Yeah. No, I should probably move to tensor. These should probably be removed again. This gate was a big win. Ops is like a really core part of tinygrad. The pattern matcher is here too, and that should probably be moved out. Like UPat's here. This should be moved out. It should be moved into upat.py. I don't know why this is here. This really shouldn't be here. I don't know about that. This needs to be moved to the grouper. Spec is fine. Tensor.py. Oh, someday we're going to be good enough that we don't need these anymore. I think we're almost there today. This is some of the oldest code in tinygrad. They're hacks for Qualcomm images. And then here's a brand new UPat compiler. Well, tinygrad. It's amazing how much can fit in so few lines. There's a lot of junk here that needs to go. What does a UPat compiler do? So we still have the interpreted UPats. It just makes UPat matching faster. It dynamically builds Python code to make UPat matching fast. That needs to move. The multi-refactor needs to happen. Tests. Yeah, you just exec it at the end. That's the exec. Nice. Where is this merge views things used? Why is this imported from here? So that PR tag means that it doesn't change anything. It's just a refactor. And tinygrad will check to the best of its ability that that's true. It's not even used. It is used in this one. Yeah, it definitely needs to move to you, Pat. This thing is a nightmare. Wait, it's returning constant? Oh no, that can't be a variable though. Like, that's, yeah. Mins and maxes themselves need to be expressions. They really just need to be UOP expressions, but that gets really slow. But then variables can cancel out. There's a whole bunch of annoyances due to that. Chenyu, maybe you can fix that. Let's look at debug renderer. Maybe that can go in spec. Gradient. Look at gradient. This is some of the most beautiful code. Very proud of that one. Yeah, all the matchers need to be moved out of opts. Oh, simple math trait and math trait need to be refactored. Oh, but then like this. You can override it in tensor if you really need to. I had this as a bounty for a bit, but the problem with having any kind of refactors as bounties is you just get shitty refactors and people who are just like, but I want the bounty because I did the technical thing. It's like, no, you have to have taste. I mean, you have to kind of have taste for features too, but at least like it's really easy to do a refactor. It's really hard to do a nice refactor. A feature can be like hard to do, and then that already like is like a natural barrier. You get people who like are no way in the caliber who could be solving tinygrad bounties who do the refactors, and like no, the best people should be doing refactors. Like our most talented engineers should be doing refactors. And all this graph stuff now. Merge this batch graph this morning, so now we have LVM there as well. It's all right. Gotta pay that bounty out. We'll do that. CUDA graph. This just needs to become rewrite rules. So much more of this stuff needs to be rewrite rules. There should probably just be a net.py. From codegen import get rewrite for renderer. See if that breaks any imports. Nope. And sometimes you get circular imports and stuff. Great. So that's just like, that like really just is code gen. Render should probably become a subfolder of code gen. Because it really is just code gen. I don't know. A different refactor for a different day. Data sets. It's beautiful. Like base classes and NN. State. It's okay. Torch, ggof. tinygrad supports everything. Right, so what's it going to take? What's it going to take to get lots of people using this? We'll open that one up to non-subscribers. No going off topic. What do you mean by marketing? I generally don't agree with this. I generally think that like the market is efficient and people find the best stuff. Like there's still like jankiness about some things. Yeah, but I mean Mojo does not have traction either. I don't know anyone who's ever used Mojo. Approach big hardware developers. Why do you guys get in your head? Why do you guys get in your head that like business development is a good idea? It's not. It's just not. Comma, why don't you approach car companies? Yeah, 10 startups tried this and they're all out of business. Like when are you going to realize that business development is just not a good idea for a startup? You're just like showing up and being like, hello, can I be your bitch? And you know what the worst part is? Half the time the big companies still say no. Hello, my name is Kyle Vogt, Mr. GM. Can I be your bitch? Dominate benchmarks. That I'm liking. I think you're right about this. I don't know if it has to compile. I mean, it's faster than Torch compile. Our compile speed, I mean, yeah, our beam speed is too slow. Like, you're right. Yeah, papers, people need to start using it. Chenyu always just repeats this thing. He's like, well, why doesn't comma use it? Why is comma still using PyTorch? And then the shame comes out, and it's like, well, this is not as good as PyTorch yet. Anything's faster than XLA compile, yeah. No, the compiler's fast. It's not that. I think that, like, for the big cases, like training on NVIDIA, it's not good enough yet. But for all of these embedded and niche hardware cases, this is so much better than everything else. And like that's what comma actually uses it for. We should move the DSP. Quaslin, we gotta get the DSP stuff upstreamed. Yeah, we gotta dominate benchmarks. I think that's really it. There's no people will switch. People will come for the speed and stay for the usability. I don't think people ever come for usability. People come for features and stay for usability. I think that's basically the way to think about it. So we have to just start being faster than everything else. We're almost there. The whole whiteboard behind me is clean. We're just going to start writing stuff down. Are you guys ready to start writing stuff down? Let's go to the whiteboard. I don't know if anyone can see shit. Okay. O of n becomes O of 1. The problem with being fast in the speed of light is that you need to live in darkness. It's interesting. And the problem with being faster than the speed of sound is that you need to live in silence. No, I hear the Concorde is still loud. I don't get it. If you're sitting in front of the engines on a Concorde, why is there sound? Like, shouldn't if the engine's behind you? I think it's because the whole thing vibrates or something, but I don't get it. Like there's got to be a way to make a plane that's silent if you're going faster than the speed of sound, and that would be sick. Wait, no. We're talking to GPT about this. Can you make it silent inside the front? Well, how fast do I have to go? Supersonic aircraft. Yeah, no, I know. Just... We'll go back to the whiteboard in a minute. We just have to go on this tangent. Sorry. Like, I used to have questions like this and never really come up with a good answer, and now you can just ask GPT. You can just go higher. The air inside is stationary. Yeah, but like, can I like build like an air bearing? You know, like, what if I mount the engine in an air bearing and have a little bit of supersonic air going around it to carry all the sound away? Does this work? Because that'd be the sickest thing. Imagine you're on a plane and it's silent. To be fair, like A350s and 787s are good. If you're in like first class on an A350, it's pretty good. I don't know why my GPT's like broken and does that though. But I gotta just do this. This is just gonna take a week. Warp, upcast, speed. We might have to merge locals first. Locals. I don't know. Locals already kind of work. Just there's no support for them. Oh. Structure-borne vibration from the turbulent boundary layer. Hydraulics and the environmental control system. Oh, but this is the same shit that works on a non... Interesting. I think after we have these three things, we already have fuse. So like fuse is done. This one's not really needed. I could put that one on hold, but it's just frustrating how slow everything is with like BERT and stuff. Like it was just stupid. Like a ton of time was wasted on not having this. Yeah, 787 is pretty good too. Okay. All right. I mean, I think that's just. Once we have this, compare to Triton. Well, I mean, so there's like warp upcast and there's locals upcast. I should read Triton. Let's just talk to ChatGPT about it. Doesn't buy you a quieter cabin, but it won't meet them. Oh, acoustically harder. Oh, that sucks. What a scam. Okay. Yeah, it's the $200 a month one. It's the best one. How is it not worth $200? Oh, I dropped pizza on the floor. I didn't zoom back in. Oh. I think it does it as like the level of the entire locals. What? No, I mean, okay, we don't want to. Should be warp because it's 1D. I see. So once it's lowered, it works warp by warp. That's the other thing too. I'm going to get rid of the specials, having like GIDX 0, 1, and 2. There really isn't a 0, 1, and 2. That's not real. There's only like a G and an L. And then L is actually also like a W. But that sounds like stuff for the next stream. I am in San Diego. This is the comma office. Has anyone here actually been in a supersonic jet? No one here has been in a supersonic jet, have they? Maybe. I mean, maybe we've got some old people here who were in a Concorde. All right, maybe we got some Air Force people. But I don't even know how often the Air Force flies supersonic. Yeah, you have to be older Air Force. Like, and if that's not proof to you that something in the world is worse, we made the money fake and the jet slower. And that's where we're going to leave today's stream. I used to have a political party idea called the Shut It Down Party, and we were going to shut the federal government down. But that I don't think is going to happen. I think that libertarianism is not what's going to work. Libertarianism is an obvious idea, and it's never been tried. So if you're a libertarian, you should reconsider your political stance and become an accelerationist. And the key thing about being an accelerationist is you want numbers to go up. So I'm starting a new political party. It's called the Number Go Up Party. And literally we're going to make a big list of numbers that we want to go up. And then we're going to make them go up. And you're going to judge the success of the Number Go Up Party based on how much the numbers went up. What do you think? Some numbers will make negative because those are bad numbers, but they still go up. Okay? Like all numbers go up. I think it might be time, right? I think that's really like my other party, and I actually own shutitdown.us. I was going to run as the Shut It Down candidate, but that's way too libertarian. You can't be libertarian. You just need to outgrow the problem. And the NGU party is going to exactly do that. With the NGUs, we make numbers go up. Do we have a strong opinion about things? Yes. And it's that the number goes up. And you can choose what the number is. And, you know, we can either make it go up or go down. But up is good. And that's up only. Sometimes some will go down, and that'll be sad. But that's not what we want. And you can judge the success of our party. Like, every party should publish numbers and then should be evaluated on the numbers. Remember when the Republicans said they were going to cut the government? Well, they didn't do that shit. They spent a lot more money. They spent even more money than they spent last year. Right? That's a bad number. That's a number we want to go negative up. But it's still up. So no more Democrats, no more Republicans. Just number go uppers versus degrowthers. The XLs, the accelerationists versus the decelerationist. I said this shit years ago. We have way too many decelerationist, and we need more accelerationists in government. And we are a great accelerationist party, and we are going to make numbers go. Come on. Wait. Are any of you guys not going to vote for the Number Go Up party? Is anyone not on board? Is anyone against the Number Go Up party? Like. No, I'm open to who's against this? We want our votes to go up. What's the end game? There's no end game. The numbers just go up and up and up. Oh, ultra scientism is a degrowther. We got a degrowther. Wait, wild nature? That sounds like a number. We'll make it go up. No, the negative. Homeless population is a negative number. Deep space is definitely a number we want to go up. Number of trees go up. Absolutely. You like European anti-accelerationism? Okay, some people can't be saved. Some people, yeah, make homeless rich again. Oh, I love that. I love that. We got so much good things going. No, brain fart says bad. Some numbers are bad. We want them to go bad. Number of buildings? Hell yeah, that's going up. All right, so we literally have a degrowther and a decelerationist. But otherwise, number of billionaires? Hell yeah, that's going up. Lifespan? Uh-huh. Who decides which numbers should go up? I mean, like, yeah, we'll just, like, make a big list. tinygrad ends with me making a chip, and my foray into politics ends with me being president and making numbers go up. No, inflation's a bad number. It's going to go negative up. Deportations? Yeah, it's going to go up. Yep, that sounds up. No. tinygrad line count? No, that's a negative number. Negative number. Yeah, energy. Energy numbers are our key numbers that we want going up. Energy's going up, right? Everything real. Gold. Number of golds that we have is going up. What's the point of going up? Are you a European style DC? Oh my God. Oh my God. What's the point of going up? Bro. Number of wives Elon has? Sure. Okay, yeah. I'm sorry, Europeans, but like, your number is going to stay here, and our number is going to go way the fuck up. You know who's right now running the number go up game? China, and they're beating at us. No, what goes up doesn't go down. That's not how it works. See how Grok is a leftist? I don't think Grok's a leftist. I think I've seen some of those. EU laws are going up. No. Laws are going down. The EU is a suicide cult. It kind of is. Right, my number of pounds go up. Put on that weight. Nah, but like energy, that needs to go up. Buildings need to go up. Did I not like Europe when I visited? Not really. Dude, I live in Asia. Like, I like Asia a lot more. Like, it's fine. It's not like terrible. It's a middle income country, and it feels like a middle income country. Like, my favorite place in Europe was Poland. My least favorite place is Portugal. Like, Poland is pretty pro-growth, like, as far as Europe goes, and Portugal seems like, oh. You're from Portugal? I'm sorry. Yeah, right? You know what's up. Yeah, Poland is sweet. Alright, if I really run for the number go up party, I'll go on Rogan. You're just trolling? Sweet. See, no one seriously believes in this shit. Because we have good internet in Portugal. Well, you see how fast my internet is? The number's going up. Two plus 2 equals 4. That number can stay. That one doesn't need to go up. All right, guys. In next election, we need to hold people accountable for making numbers go down and making numbers stay the same. We need to hold people accountable to numbers going up. If we can all get behind that, there's no limit to what we can accomplish. If everybody believes together that the numbers should go up, and we hold people to that high standard, we can win. But if we just are lax and languish about numbers, or even worse, making numbers go down, we will lose, because China makes numbers go up. And if your numbers don't go up, China's number will be so big compared to your number that you won't even notice your number anymore. Have you ever added a really large number to a really small number? Sometimes when you do this with floating point numbers, this really small number doesn't even do anything when you add it, and all you get back is the really large number. And that is what will happen if we do not embrace numbers going up. So everybody get out there and tell your friends, tell your neighbors, tell your parents, tell your siblings that we need to make numbers go up. And that's why I'm running for president in 2028 as part of the Number Go Up Party. Who's with me?